Hi guys, it's been a while since the last upload. I'm still working on the plate reverb. I managed to get all the electronics done and I built a remote control and it's working now. Now, as you might guess, I have about 1,000 of these boxes laying around, so I figure, hey, why don't I just use one for the remote control. Now, once upon a time, I ordered some switches and I got the wrong ones, and that was my fault. But I did find a use for at least one of them today. This is going to go into the remote control. Now this is a double pull, double throw toggle switch, and it has some springs in it, so it will always go back to the center position. The center is off, so it's either on, off, or on. And that's going to work just perfect for this job. So I have two LEDs that are going to be mounted in here with these little grommets, and one will represent the minimum setting of the dampening panel and the other one will represent the maximum setting of the dampening panel. So when these light up, you know to take your finger off of the switch. And then there will just be one cable connecting to this via 5-pin XLR jack. It should be pretty simple to put together. These unit bits are awesome. This is one of those larger unit bits, goes up to 1 inch, and that's what I'm going to need to drill the hole for the XLR jack. Well, not much to look at here, folks. This is pretty simple. It's just a momentary switch, a couple LEDs with dropping resistors, and a 5-pin XLR jack. That's all there is to this remote control. Most of the electronics are actually housed in the power supply. I wasn't able to do what my original plan had been, and that was to power the motor and get the remote sensors to work, all off of the same cables that the audio is transmitting down. Unfortunately, that just wouldn't be possible as I thought about it more, so I had to go to Plan B. Plan B is to, unfortunately, run a whole extra cable. So I didn't want to go through the floor, and I did not. What I'm planning to do is go up through the ceiling, down a ways to a bathroom where I can then go through just a regular floor, which is plywood, and there's actually already a hole there for the plumbing, which I'm going to utilize to get down to the reverb. Now that is a much further distance, so it has to go 63 feet, I measured. And I tried running the motor off of just this cable and having the power supply transmit the power all the way down. It didn't work. 63 feet is just too far. There's too many losses with the DC voltage going through there. So the only solution, and the one I actually thought of way back, was to put relays down at the plate reverb and have the relays just getting their low current signal going all the way up to the remote control, and then flipping on high current to power the motor down here at where the reverb's going to be. So that's what I ended up doing. There's 4 relays inside of the power supply. I'll show you that in a little bit. Those relays are single pole, double throw, 12-volt relays that are 10 amps each. There's 4 of them, and they basically just flip the polarity of the motor and they stop the motor when the switch is in the middle. Check this out, guys. And that just tells you, take your finger off the switch, you've reached the maximum distance. And then back the other way. And of course, you could stop it anywhere in between. You don't have to go all the way. So it's variable. There we are. Awesome. So the next step now is going to be routing this big ass cable up through the ceiling, and that's going to be a big job. I'm going to get some help for that one. Hi guys, we're in the control room now, and I'm going to drill through the wall up here because that's way easier than drilling through this concrete floor. So the idea now is I'm going to drill through this wall, go over a hallway, and then through another wall, and then into a bathroom and through the floor down there, because that floor is just plywood. And there already happens to be a hole for the plumbing, which I can utilize for the remote cable. Now this whole thing is a much further distance, so that's why I'm using a 66-foot cable instead of what would have been probably a 30-foot cable. But it will work, and this is probably the best solution. So here we go. Wow. Here we are in the bathroom. Well, there you go, you're through. That's perfect.
Dude. Awesome. Extra, a ton of extra. What side of this did you think we could go? Oh, I can see it, Mike.
Yeah, I think if we can get behind there, I'll go down in the basement and grab it.
Yeah, let's do this. Sweet. Oh, I think we're gonna be fine.
Yeah, well, I need 10 feet of cable downstairs. I'm not sure.
I'm not sure you're fine.
Well, I wasn't going to show you this because I think it's pretty ugly, but here it is. It works, and I know there's going to be somebody out there that wants to know how I did it. This is the power supply for the motor, and it also controls or receives control from the remote control. Now, I kept this as simple as possible and kept the cost down to virtually nothing by recycling parts. This case has been used at least 3 other times for various prototypes, and all these parts are salvaged, so really it didn't cost anything to do. And to spare myself the cost of time and money to create a circuit board to house the electronics all nice and pretty, I just used some tag strips to build my rectifier on, and then I hot glued the relays in there. So 4 Schottky diodes and a bridge rectifier configuration giving me about 20 amps DC at 12 volts with the filter cap on it. And then I have my big relays here, which are 10 amp relays. These are single pole, double throw, 12 volt relays. There are 4 in total, and they're essentially wired up in 2 pairs. And they control the directionality of the motor and its on-off status. Now these relays are getting their power to power the coils within them from the bridge rectifier, but it's going an extremely long distance, a total of 132 feet. So it goes 66 feet out to the remote control in the control room, and then back down to tell these to turn on or off. Their normal status is off, so if they receive power from the remote control, they kick on. If you flip the momentary switch one direction, one bank turns on and sends positive and negative voltage to the motor. If you flip the momentary switch on the remote control the opposite direction, then that goes to off, and this bank turns on, which is the opposite polarity. So therefore, the motor will move in the opposite direction. Now, these relays are receiving high current, 12 volts from here, and feeding it through to the motor through a very short cable that connects out of this box into the reverb. That cable is about 3.5 feet long, so that means that the total cable length from the rectifier to the motor is very short, and that I have found is extremely important. If you were to try to power the motor from 132 feet away, the power supply would need to be really freaking huge. I mean, this thing is already very big, but it would have to be unnecessarily large to be able to do it. So this is really the best solution. And actually, to tell you the truth, after I put the relays in here, I no longer needed to have such a big power transformer. But since it was already built, I just went with it. I'm not going to waste any more time. So it works, as I said, it's fairly simple. Well, I hope you're finding this video series to be interesting. Please continue watching as we get close to the end.